GABA, the brain's primary brake and the foundation of calm and control. When people think about brain chemicals, they usually focus on those that excite, motivate, or energize. Much less attention is given to the chemical that slows things down. But without inhibition, the brain would not function at all. GABA is the brain's primary inhibitory neurotransmitter. It acts as the nervous system's brake pedal. Without GABA, thoughts would race uncontrollably, movements would become chaotic, and the brain would quickly overload itself. To understand calm, control, and stability, we need to understand GABA. The story of GABA begins in the mid-20th century. In the 1950s, researchers discovered that gamma-aminobutyric acid, or GABA, was present in large quantities in the brain. At first, scientists assumed it was simply a metabolic byproduct, but experiments soon showed something remarkable. When GABA was applied to neurons, it reduced their activity. Instead of exciting neurons like glutamate, GABA made neurons less likely to fire. By the late 1950s, GABA was firmly established as the brain's main inhibitory neurotransmitter. This discovery helped explain how the brain prevents runaway excitation. So, what does GABA actually do? Well, at its core, GABA reduces neural activity. When GABA binds to its receptors, it makes neurons less responsive to incoming signals. This does not shut the brain down. Instead, it fine-tunes activity, preventing excessive firing and allowing information to be processed in an organized way. If glutamate drives neural activity forward, GABA keeps it under control. Healthy brain function depends on a balance between excitation and inhibition. GABA plays a critical role in anxiety and emotional regulation. When GABA activity is high, neural circuits involved in fear and stress are dampened. This produces a calming effect. When GABA activity is low or poorly regulated, neural activity becomes excessive. This can lead to anxiety, restlessness, and heightened emotional reactivity. Many anxiety disorders are associated with reduced GABA function or impaired inhibitory control. GABA is also essential for sleep. During sleep, especially deep non-REM sleep, GABA activity increases. This suppresses wake-promoting brain regions and allows the brain to disengage from the environment. Without sufficient GABA activity, falling asleep and staying asleep becomes difficult. This is why many sleep medications enhance GABA signaling. They do not create sleep directly. They reduce neural noise so sleep can occur. GABA is crucial for motor control. In motor systems, GABA helps prevent unwanted movements. It ensures that only the intended muscles are activated, while others remain inhibited. When GABA signaling in motor circuits is disrupted, movement becomes unstable. This can lead to tremors, muscle rigidity, or involuntary movements. Smooth, coordinated movement depends on precise inhibitory control. GABA also plays a major role in cognition. It helps regulate attention, working memory, and information flow. By suppressing irrelevant neural activity, GABA allows important signals to stand out. This improves focus and reduces mental clutter. Too little inhibition leads to distractibility and cognitive overload. Too much inhibition leads to slowed thinking and reduced responsiveness. Again, balance is key. Here are 5 everyday examples of GABA at work. First, when you feel calm after a stressful moment passes, GABA activity helps settle neural circuits. Second, when you are able to focus on one task without being overwhelmed, GABA is suppressing distractions. Third, when you fall asleep and your thoughts slow down, GABA is quieting wake-promoting systems. Fourth, when your movements feel smooth and controlled, GABA is preventing unnecessary muscle activation. Fifth, when anxiety feels overwhelming, reduced or ineffective GABA signaling may be involved. Because GABA is so important, disruptions to GABA systems can have serious consequences. Too little inhibition can lead to seizures, as seen in epilepsy. Excessive excitation without sufficient GABA control allows neural activity to spiral out of control. On the other hand, excessive GABA activity can cause sedation, slowed cognition, and impaired coordination. This is why substances that strongly enhance GABA, such as alcohol or certain sedatives, impair judgment and motor control. There are several important facts about GABA that are often overlooked. GABA is the primary inhibitory neurotransmitter in the adult brain. It acts through multiple receptor types, including fast and slow inhibitory mechanisms. Many commonly used drugs act on GABA systems, including benzodiazepines, alcohol, and some anesthetics. GABA works in constant balance with glutamate. Disruptions in GABA balance are linked to anxiety disorders, epilepsy, insomnia, and some mood disorders. So what is the big picture? GABA is not about excitement or reward. It is about stability, control, and balance. It prevents the brain from becoming overwhelmed by its own activity. If glutamate provides acceleration, GABA provides braking. If dopamine drives pursuit, GABA prevents impulsive overload. And if acetylcholine sharpens clarity, GABA protects the brain from noise. Without GABA, the brain would be fast, loud, and unstable. With GABA, the brain can think clearly, move smoothly, and rest when needed.
If you enjoyed our channel, please click subscribe.